Hello again. This is Mark Summers from Summers Technical Services. We're going to move on to another Solidworks part model. This one's the legendary double V block, and we'll be able to use some new features. We're going to learn about the hole wizard, which will let us do parametric tapped holes, parametric clearance holes, and counterbore holes. Lots of different types of holes. That's going to be very useful to us. So let's get started. Alright, so our part, which is passed out during class, is this guy right here. This doesn't have the dimensions on it, but first thing we need to do is come up with a strategy to make this part. And so it looks like a bunch of extrudes. Not only extrude joins, but extrude cuts is what we need for this part. And what I want to do is find the view that's going to be the most descriptive. And I think that view looking for what I'm going to call the front is going to be the best view to start with, because that face, that shape on the end here, far right, is constant throughout. We could make that one extrude, and then we could just whittle away that middle section at the top, and then do the holes, and I think we'll be done. So every time you start a new part, you need to spend some time, come up with a strategy, and that'll save you a lot of time in the long run. So since we want that orientation like that, we need to make sure we select the appropriate plane to get started on. So I'll pull that aside and start a new inch part model from our nice templates we have, and make sure I'm going to start off in my ISO view so I can choose that the correct starting plane to sketch on. And so there's my ISO view, and so I want to start on this plane right here. And I think, yeah, that seemed like a good strategy, because the part, let's bring it back in real quick, that's the plane I want to sketch on to make that first shape, which is basically this end face down here, across here. Alright, so now that we've got the planes figured out, and then the other planes, real quick, kind of goes without saying, but the bottom of the part, that's where the top plane is going to be defined. Makes sense, because the part's going to sit on the shelf somewhere. We'll have that represented by the top plane. And then the front plane, I think would make sense to make it go right through the middle of the part. This part looks symmetric. And so let's put that front plane right through the middle of the part. Alright, so I select the plane, I go to the sketch tab, and then I will select the sketch command, go into a 2D sketch. Okay, now I'm going to go to my line command, and I'm going to again make these sharp corners instead of doing fillets, because I want to not to put fillets in my sketch unless absolutely necessary. So I'm going to try to pay attention and make these lines vertical and horizontal. So it goes up this way, it goes over this way, not quite as far, and it goes up, and it goes over, and it goes down, and then across, and then back up, over, down, and then over here, and then straight down. Alright, right click select. So I actually made a closed loop, so that's good. And it doesn't look horrible. I've got some of these are missing. This guy didn't quite make it to vertical, so I'll make him vertical. And this guy didn't quite make it vertical. And otherwise, I think I was pretty successful. Alright, so I think I'm going to put me a, just for fun, I want to put a center line through this part here. And so I'll go pull down the line command, and instead of doing a regular line, I'll do a center line, just to keep me reminded that this thing is symmetric about the middle line. And when I put a center line in, I like to make it infinitely long, because it doesn't necessarily have a stopping point. And I'm going to tie that to the origin And now it looks good. And we can take advantage of some symmetry constraints that we haven't learned about yet. So let's do some symmetry. And so you can do vertices. You can make vertices symmetric about a center line, and so you have to start off with a center line, otherwise the symmetric constraint doesn't work. And so if I select the one of these vertices, as soon as Solidworks comes back to life here, that vertice, control click that vertice, control click the center line. Now I'm going to get another option for symmetric. And now those are symmetric about, those two vertices are symmetric about the center line. So I can select this guy and this guy, and again select the center line and make those symmetric as well. And when I do that, as I drag these edges around, this edge right here, I think it's the one I did, there's a constraint right there, so that is it. So you can see I've got these symmetric, and I believe this one's also symmetric. So that's good. And then now maybe I could do these two vertices symmetric, or I could just make these equal. Does the same thing. So I use a mixture of these things. Let's make these equal. And what else? I don't know what else. So let's click and hold and drag something around. Now I can see I need another symmetric or another equal. Let's make this and this. Control click. We'll make those symmetric just to kind of spice it up here. And now again I want to see how it's behaving. That looks pretty good. Are these collinear at the top? No, they're not. So I want to make this line and control click this line. Both lines are in the blue box. Make those collinear. These guys here are collinear. These guys here are collinear. So this is looking geometrically constrained. I'm a little bit worried about this guy here, and so I want this to be in the center. I could put a midpoint on here, but this center line has kind of got me all excited, so I want to use it again. There's a vertice. There's a vertice. Oh, I thought it was a vertice. What happened? We're waiting on slow Solidworks. So I want this vertice, that vertice, and that center line, all control clicking. Alright, now I'm pretty sure I am geometrically constrained. So now I'm ready for, oh, I need one more thing. I need to tie this origin down so the top plane is where it needs to be. So I want to grab that line, control click the origin, and make those coincident. Now the top plane is at the bottom where I want it. Alright, so now maybe I'm ready for some dimensions. And you'll notice that the handout shows all these dimensions coming from a common edge, which is the way I like it. These dimensions start, a lot of them start on this edge over here, and some of them start at the bottom edge. So we're going to use those edges as a common edge, just like it is in the handout. So we're going to click the edges, click to place the dimension, and then click to change it. So that's 1 inch, or that's a 1/4 inch. And then we go 2 inches over to here. Here to here is 2 inches. Click to place it, click to change it. And we're going to go all the way across. And some of these values are, all of them are two-place dimensions, but the design intent, I think whoever designed this thing was thinking in fractions of an inch. So these ones that are rounded off, we're going to change them to match what the design intent is, which is this is 2 9/16, so we'll make it 2.5625. And we'll keep going, and maybe we'll do these vertical dimensions. Here to here is 1 1/4. Whoops, what happened? Here to here is 1 1/4. Come on, Solidworks. You can do it. Here to here. Click to place, click to change. 1.25, and then we got 1.5 up to here. And we'll keep going. 1.88 to the bottom of this notch, but that's really 1.875 to the round off error, or the round off of the two-place dimension. And then we'll go up to here. That looks like 2.75. And now up here at the top, for some reason, they started from this edge and moved over, so we'll do the same thing from this edge to this edge. Oh, wait a minute. My sketch is not right. This thing goes down and it goes over. No, it goes down, then it goes straight down. This is not right. So I got to fix. I'm going to delete that line. And I'm going to go add another line, or new lines, to go here to here, here, here. There we go. That looks like the sketch. And so now they're saying I'll drag it closer to what it's supposed to look like. There we go. So now I can continue on my dimensions, I think. So we want to go here to this edge. Wait a minute. That doesn't look right either. What's going on in here? That is not good. I knew something was wrong because this thing is not shaded in anymore. It's not a closed loop. And so I can select that point, control click that point, those vertices, and merge those together. By the way, don't ever use this fix constraint. There's an option for a fixed constraint. Students see the fix constraint and they think, oh, that'll fix my model. No, that'll make it fail miserably, because what it's doing is fixing the point at whatever location it happens to be at. So if you use that fix command right here, the boat anchor, it's just like hanging on to a boat anchor and falling off board. You're going to go to the bottom of the ocean. You don't want to use that, because what that does, it fixes it in place and makes it so it can't move, which you think is good because your sketch is constrained now, but now it's in some location where you don't know where it is. And if you select these entities, you also get these parameters down here. It gives you an angle and a distance. If you type in values here, that is, it's okay. And now that line is 0.25 inches, but it's not dimensionally constrained. I can still drag this point around, and now if I select it, now it's some other distance. So this is like a speedometer. You're going down the road, you look at your speedometer, it tells you what your speed is at one point in time. But, 3 miles later, you get pulled over, and you say, hey, how fast are you going? Well, my speedometer said something 3 miles back. Well, that doesn't mean anything. This is a speedometer. What you want is a dimensional constraint that's going to make it actually be fixed. All right, so here to here was 875. Now that I've got that line correctly drawn. And this thing went cattywampus on me, so you got to keep an eye on this thing. Drag it back. That looks better. And we'll go 1.125 over to here. It's not what I wanted. Here to here. 1.125 is the design intent. And then all the way to here. Oops. I want a line to a vertice. That should be able to give me a distance. And that's going to be 1.75. And then I got 2 inches all the way across. So this is coming together nicely. Now it says it doesn't need that dimension. Adding this dimension will make your sketch over-defined. And so I want that dimension on there because I want to be able to use that in the drawing. But the reason it doesn't need it is because of this symmetric constraint I added earlier. And these yellow highlights are saying, hey, because of these geometric constraints, I don't need to know that. But what I want to do is, instead of using this dimension to drive the sketch, I want this dimension to be driven by the sketch. And when I say OK, now that dimension is there, but it's not driving anything. And I can tell it's a reference dimension because it's dimmed out. See how it's gray instead of black? So that dimension is not driving anything. It's just reporting what the current value is. All right, so let's keep going here. Let's make this 90-degree dimension here. And I want to put a minimum amount of dimensions on here. So I could do another 45 dimension from here to here, 45 degrees. But I don't like to put dimensions on here when possible. So I'm just going to select this line, control click this line, and make those perpendicular to one another. And oh, that's not going to work because it already has the 90, so that was a bad idea. So I'm going to not do that. And since it's symmetric, I think it's going to be okay. Now I need to add another dimension to this other edge here, 1.875. I lost this when I deleted that line a minute ago. So from there to there, put it over here where it belongs, 1.875. So I'm slowly getting this thing constrained. On the very bottom, this step at the bottom is a 1/4 inch. So let's add that. As soon as Solidworks decides to come back to life. And we'll go here to here. And that is a 1/4. All right, now what? Still says under defined down here, so what needs to be defined? Well, there's something blue. Let's drag it around. I need to know how tall that step is there. And I think what I need is what? I'm not seeing it. That's 1.875 is on there. What am I missing? 275 to the top. Side to side, I got 875, 125. What is missing? I'm not seeing it. I don't have a height to that step. What if I put this? I don't think this is it. I don't think I need a 45 here, do I? Yeah, that was it. I need half of 90 to tell that is symmetric. Could have used a symmetric constraint, but there it is. Now it's fully defined. It says down here everything is black. Get out of the sketch. Do a space bar. ISO view. Now I'm ready to select the sketch, go to features, extrude boss base. Now here's where I want to get strategic here. I want to type in this 4-inch distance. I want my plane to go right through the middle of the part for reasons that'll be clear later. And if I do blind 4 inches, it's going to start at the sketch plane and go 4 inches. But I want the plane to be in the middle of the part, so I want to change blind to mid-plane. And now the sketch is in the middle where the plane is, and it goes 4 inches, but it goes half one direction, half another. 2 inches this way, 2 inches this way. And if I do that, now the plane is right in the middle of the part. Well, that was already in the middle of the part, and there's the bottom plane. That right plane I sketched on is now the middle of the part. And that's not important now, but it's going to be important later when we do our assembly model tomorrow. All right, so now I need to start whacking away at material, and all I need to do is sketch on this face and cut up to get rid of that middle section. So I'm going to say sketch on this face, sketch, and I'm going to make a rectangle, except I'm going to locate the rectangle by using this edge here. I want the rectangle to go across here, but I want it to stop right here on this edge. And so I want to place the first edge there. I'm going to place the second edge over here. And now it already knows where the end of the rectangle. See how those lines are black? That line right there is on that edge, and this line right here is on that edge. Now all I need to do is dimension the width of this cutout, which is 275 minus 1 1/4. And so this face, or this edge to this edge, is going to be 275 minus 1 1/4, whatever that is. And now the only thing I need to do is locate this thing so it's in the center of the part. And since I've already got my plane in the middle, I could do something as simple as putting a midpoint on that line like we did yesterday, and then make that point in the origin, if I can find it. That wasn't it. Right click, clear. I need the origin to pop up here. Maybe I'll find it on the tree instead. Sometimes it's easier just to grab it in the tree. So there's the origin, and I lost the point. So there's the point and the origin. Make those line up vertically, and now it's fully defined. So I'll get out of that sketch, and I will do an extrude cut, and I'll do it through all going up because I want it to cut all the way through the part. Get rid of that middle section. So we'll go back to feature. It's not out of the sketch yet. What's going on here? There we go. So the sketch, the minus sign's gone away, so that's good. Select the sketch, features, extrude cut, go all the way through. And right now it's chosen the wrong direction, so I'll flip it. And now it's golden. All right, that's looking pretty good. Now it's time for the hole wizard. I got 3 holes. These are the holes we drew on our exam. We call this the A hole. The B hole we didn't do, but we'll do it today. And then the C hole goes in from the side. So we're going to learn about the hole wizard. It's a new command, so this is exciting. So let's click on hole wizard. And the A hole over here, we want to do a tapped hole. So I get all these options. This is what's cool about the hole wizard, is you get to choose. You get to choose what type of hole. So you can do counterbore holes, you can do countersink, you can do tapered tap holes, like for a pipe thread we learned about, straight taps. You can do anything you want. And so we want a straight tap. I want to do an ANSI inch. I just answer these questions top to bottom. And we want to do, in my case, is a 3/16. Yours will be different based on the numbers I give you in class. And this thing is going to be blind. And it says the tap depth is 0.625. And so there's 2 columns. I don't want to go up to service. I want to go blind. And so this number here, this is the blind hole depth. And this is the tap thread depth. So this is the tap depth. And according to the drawing, it's 625. 0.625. And then this tap drill depth, this is, you're going to calculate this tap drill depth using that K factor that we used on the homework and the exam. Solidworks has a way to calculate what it thinks you want to do for the tap drill depth, and that's what this little link button here is. And so it's guessing what I want to do for the tap depth, and I don't have my catalog handy, but so I'll leave it like that. But you're going to want to change this value based on that K value. And down here, you're going to want to make sure this middle option is chosen so it shows you as a cosmetic thread. You want to have a thread call out. You want to have a thread class. You don't want this near side countersink. So those options are good. And now I'm going to hit the next button. It's on type now, and I've answered all these questions. Now I'm going to go positions. And it says select the face for the hole, which is this face right here. And now it says select the location. Well, I'm just going to click here on the screen and then say OK. That's a beautiful thing. It's made my hole there. Now it doesn't show it as a tapped hole though. So we need to fix that in a minute. But the first thing we need to do is look inside the hole wizard feature and notice there's 2 sketches. There's a sketch for the shape of the hole, which is based on the size we chose. And then this is the sketch that shows where that hole is located. And since we just clicked randomly on that face, it's not constrained. So every time you do a hole wizard, you need to open it up, right click on that locational sketch and say edit sketch, and you need to constrain it. And so I want that point and the origin to line up vertically, because that's what the drawing tells me to do. Oops. Grab the point where the hole is located. There's that origin, go vertical. And now I just need a dimension, and according to the sketch, it's 0.625 from here to here. So this sketch, all it has in it as far as geometry goes is points. And everywhere I click, it would have put another hole. So if I want another hole just like this one, I could click and add more points to the sketch. And it would put them on that face. So now that sketch is totally defined. Now I need to turn it on so I can see that cosmetic thread on the screen. And so we're going to come over here to this pull down right here with the eyeball up here. This is our visibility settings. And if I pull that arrow down next to it, these are all the things I can turn on and off. We've already done planes before. And what I need to do is turn on and off these annotations. So I'm going to turn those two on. And when I click off of it, now you can see it's got the major diameter. There's the tap drill hole. And it makes it look like a tapped hole, which is pretty cool. So now that's good. I can take a look at the inside and see what this thing looks like. I'm going to grab the front plane. And here's a little section view up here. And you can click that and say, okay. And you can kind of look through the middle of this thing temporarily and say, yeah, that looks like my tapped hole. There's the tap depth. There's the tap drill depth. There's my 112 degree chisel point there on my twist drill. So that looks good. So I'm going to click and turn that off. All right, so that was the A hole. Now let's go to the B hole. B hole is right here at the top. No, the B hole is over here. We'll do the B hole last. C hole is up here. And so we're going to again use the hole wizard. And in my case, I had a 3/8. What did I have? No, I had a 7/16 20 socket head cap screw. No, I had a 3/4 16 socket head cap screw. And so I'm again use the hole wizard. I'm not going to drill a tapped hole because I need a counter bore hole. And there it is right there, counter bore. And these options change. ANSI inch, I still want. The type of screw is a socket head cap screw. That's the screw I'm putting in this hole. So you choose the type of screw you want. My particular screw size is a 3/4 16. So there's 3/4. And I want a close fit in my case. So I'm just choosing numbers from the table. Solidworks has all those numbers from all those tables we've been using. They're all built in. It's parametric. It's what you would expect. So 3/4 inch close fit clearance hole in condition. In this case, it's going to go all the way through. So I need to change blind to through all. And I don't need any of these options. And again, I'm through answering questions, so I'm going to go to positions, select the face, boom, select the hole position. Well, that's another reason I put this plane right in the middle. I can now choose that origin as a location of my hole and then say okay. And now all that hole diameter, the clearance hole diameter, the counterbore diameter, the counterbore depth, all of that is done per that ANSI specification, so I don't have to do anything else. All right, now the last hole is going to come from the side over here, and in my case it is a 3/4 16. So I'm going to come back to the hole wizard, and I'm not going to show you. You already know how to do it. Except the only difference is you're going to have it go through, and you're going to have the depth. Just take it to the middle plane there. Just take it to the middle, to that front plane, so that it passes through. It doesn't go all the way through. The note on the drawing says through to hole, and so that means it's going to go through here, just through this hole. It doesn't go all the way through the other side. So through the hole, just have the depth, just choose up to surface and choose that plane as a surface to stop it. Don't forget to define your material, and when you get done, you'll do an evaluate mass property check, and you'll compare that to my numbers I got for the for the mass and the volume, and that'll make sure that you chose the correct material and you did your model right. If those numbers match mine, then you're good to go. The only last thing I'm just now seeing here, we need to add those fillets down here, so don't forget to add those fillets. Looks like a 1/4 inch, 2/4 inch fillets, so don't forget to add those. And I think we're through. All right, good work. So that's our second parametric SolidWorks CAD model. We've got through. We're going to make another part tomorrow, and we're going to get into teams, and we're going to build an assembly model of these parts. So every team member's got to do their model correct. Otherwise, when you get to the assembly, you don't want to disappoint your team members. So work on this part. Tomorrow we'll do the second part, and then we'll get into the assembly model. So until then, have a good day, and we'll see you tomorrow.